Hello everyone, in today's video we'll learn how to deploy this Hello World smart contract into Ropsten TestNet. So in one of my previous videos you guys might have watched that I had created this Hello World smart contract using Solidity, and today we'll try to deploy it using Infura and MetaMask. Okay, yeah. So first thing I want you guys to do is head over to infura.io. I'll post the link down in the description. Now if you guys haven't watched the previous video, I suggest you guys to go and watch it, where I would explain how to create Infura account and how to create Infura projects. So just a quick recap. So Infura is a tool which we are using to deploy our smart contracts into a specified ethereum network, right? So in this case we are trying to deploy smart contracts into Ropsten testnet, and we'll be using the Infura API to connect to the Ropsten testnet and deploy our smart contracts. Now I have already created a Hello World project. So if you guys haven't created a Hello World project, I suggest you guys to click on new project and give a name and create it, so that it will create a new project for you. After creating it, click on your project, then go to settings. Now here I want you guys to click on this drop down which says mainnet and select Ropsten. Now this is the URL which we will be using to send the bytecode to the Infura node, so that it can deploy into the Ethereum Ropsten testnet. So copy this URL and let's paste it somewhere so that we can access it later. Next, I want you guys to install a couple of project dependencies like Truffle HD wallet provider, which helps us to create a wallet, and Web3, which is an interface which we use to communicate with Ethereum network, and Solidity is basically a Solidity compiler which we use to compile our source code into bytecode, which we can then later deploy into the Ethereum testnet. So let's install this. I'm going to copy this, clear my terminal. I'm going to paste it in my root project, the Hello World directory, and I'm going to run this. Now this will install these 3 dependencies for me. So the dependencies has been installed. Yeah. So next what I want you guys to do is create a new file called deploy.js. Now here we'll be first importing Solidity compiler, that is solc. So type const solc is equal to require solc. Next I want you guys to import fs, which is a file system module provided by Node.js. And if you guys haven't installed Node.js for this, I'd suggest you guys go to type node in your browser and go to this website and download the recommended for most users version, which is 14.17.5 while recording this video. After installing that, only then you guys can install all these packages which I told before. So sorry for not mentioning it before. So I suggest you guys download the node in case if you guys haven't yet installed it yet. Now I'm importing fs. Now first thing, I have to read this smart contract file. I have to read this data to compile it. So what I'm going to do is I'm going to fs dot read file sync, and I'm going to provide the path which is deploys in this current directory, and I have to go to current directory contracts folder. Inside that I have to access hello world dot sol, and the second parameter for this read file sync function is nothing but the encoding format. I'm giving it as UTF-8. Now I'll store this data contract. I'll call it as contract source code. I'm storing it in a variable. Next, I'll be trying to compile this source code. So what I'm going to do is I'm going to say solc.compile, and I'll be passing the contract source code into this. But before I do this, there are some couple of configuration code that we have to pass with to this compile function. I'll call it as config, and to get this configuration information, you can type solc input. Let's try this. Oh, and I want you guys to click on this solidity code to input JSON description. I'll post this link down below in the description, guys. And here I want you guys to copy this whole input value, the value assigned to this input variable, and paste it over here. Here we have to provide the contract file. Our contract file name is hello world.sol, and the content is nothing but your source code. I'm going to paste it here. Now this I'm going to inject it into this compile function, but before I inject, I have to convert this to a string, because it is a JavaScript object right now. I have to convert to string. To do that, I can use the inbuilt json.stringify function, which converts it to a string. Let's assign this to a variable, compile the code. After assigning this to variable, I'll try to print it, console.log compiled code, and I'm going to save this file, and in the terminal I'm going to type node and the name of the file, deploy.js. Yes, our contract has been compiled successfully. Now you don't have to learn about all this metadata about your source code, guys. We just need the bytecode. For that, let's convert this back to an object, a JavaScript object, json.parse. It'd be easier for us to analyze it. I saved the file, and now I'll run the code again. Okay, so here we have it. Now here I want you guys to access this contracts property. So I type dot contracts, I save it, I run it again. Okay, in this contracts folder I need ABI and as well as the bytecode. So ABI, we use it is like an API which you use in a decentralized world or a blockchain world to connect to your smart contract and to run some functions using that API. So ABI is the only way where we can access our smart contract functions, so that we can derive benefit out of it, right? Now next, I'll try to access this hello world property. I'll just copy this hello world string and put it here. I'm trying to access that property within this object. Now I'll save the file. I'll save this file and I'll run it again. Okay. Now next, I'm trying to access this hello world property. So copy that, paste it here, save it, run it again. Now guys, here you can find a lot of information like the opcodes. Yeah, these are the opcodes of our code. Now opcodes are nothing but the instructions provided to our Ethereum virtual machine so that it can perform the task, right? For instance, the opcode for add could be something else like 0x10. This is an opcode for, I don't know guys, I'm not much sure about the low level implementation of EVM. So if you guys are interested, I'll provide the link down in the description. So we can scroll to the top, and here we have the ABI here. So what I'll do is I'll try to store this in a variable const contract is equal to this, and in this I'll try to access the ABI contract.abi. I'll save this file, I'll clear this, and I'm going to run this again. Yes guys, so we have the ABI. So this is nothing but it describes what and all function we have written in our Solidity code. Here you can see we have written the get hello world function. You can go back to your Solidity source code, get hello world function. Its name is get hello world, outputs an object. So you're getting this object because this Node.js doesn't print the full details of an object. If you want that, you can convert this to a string and you'll get entire details about the object. It is some limitation of Node.js. So convert it to a string and deploy it again, or run the deploy file, and now you can see that it input is the name of the function is get hello world. The output is nothing but type string, and the type is string. The output return statement is string, and the state mutability is pure, which means that this function can neither read nor update the contract or the state variables, and the type is function, so it is of type function. Now I'm going to store this ABI in a variable. I will call it const ABI is equal to this. Now next we need the bytecode. So to access the bytecode, you can do contract dot evm dot bytecode dot object. Now if you guys are wondering how I am able to remember all this stuff, because I've done this before, so that I know which property has the the bytecode in this compiled code object. So I'm going to save this. I'm going to node deploy. I'm going to run deploy.js again. So here, so this is our bytecode for our source. Our hello world.sol smart contract. Now I'm going to store this in another variable. I'm gonna call it bytecode. Yeah. So now we have the ABI and bytecode. We can go ahead and deploy this in the the Ropsten TestNet. Now next I want you guys to import HD wallet provider. I'll call the variable HD wallet provider, and I'm going to require truffle HD wallet provider. Yes. Now this returns a class. Now to create an instance of that class. Now before I do that, I want to import another dependency called web3. Web3, yes. Const wallet. Now the truffle HD wallet provider helps us to create a wallet using our seed phrase. I'll explain how to do that in a minute. I'll call this wallet is equal to new HD wallet provider. Now this takes in two arguments, two strings. The first one is our seed phrase. Now to get your seed phrase, go back to your MetaMask. If you guys want to know how to create a MetaMask account, I have done a video. I'll post the link down in the description. Yeah, go to your MetaMask, click on your browser extension, and here you can click on this. Now here you guys can go to the settings, go to security and privacy, and reveal the secret recovery phrase. Now type in your password. Next. Yes. Now copy this seed phrase, go back to your code editor, create a file called seedphrase.txt and paste it here. Now I've already done this, so if you guys haven't done, please do this and save it. Now I'm going to take this string, copy it, and then I'm going to provide this as the first argument for this constructor, this HD wallet provider constructor, and the next one will be your Ropsten TestNet URL. Now to get this URL, you guys can go to infura.io as I mentioned before, copy this Ropsten URL, go back to your code and paste it here. Now what this is basically doing is that it is taking your seed phrase and creating a wallet using BIP39, I guess. So that is the algorithm which is used to generate the public and private key pairs, and then it is using this URL so that it can connect to the Infura node using this wallet, so that we can communicate to the Ropsten testnet, since we are using the Ropsten testnet Infura URL. Now next, create a variable called web3, and for this I'll say new web3 and inject this wallet into this. Now web3 is basically an interface used to interact with your smart contract. So you have your wallet, and using your wallet you can inject it into your web3, and the web3 provides different functions and methods, so that you can easily communicate with your wallet. You can easily communicate with your smart contract which is deployed in your ethereum testnet. Next, I'll create a function called let's say deploy, and I'm going to make this an asynchronous function. So the reason why I'm making this asynchronous function is because I'm going to run some asynchronous code in this function. The reason is simple, because whatever runs on Ethereum is not happening immediately, right? So whenever you send a transaction to Ethereum, it takes some time to validate and confirm it. Now if I send a transaction now, it takes like some 10 blocks or 15 blocks to confirm it, right? So until that time I don't want to be waiting. So what asynchronous code lets me do is, it lets me to run a code as soon as a transaction which is running in the which is now next, I'll create an async function. I'll call it deploy. Now the reason why I'm creating an async function is because I'm trying to run some asynchronous code within this deploy function. I'll create a try catch clause so that I can able to catch an error in case if the function throws any error. Okay, now if you think about Ethereum transactions, right, for example, so whenever I send a transaction to Ethereum, so it doesn't confirm it immediately. So it takes some time to run the proof of work or proof of stake, find the nonce, find the block hash, and then deploy send these blocks to all the other miners, and then adding it to their blockchain. So this takes some time. So in order to you know process these kind of code, we need an asynchronous block. So that is what we are trying to do here. So if you think about it, any interaction that is happening with Ethereum, it is not happening immediately. It is not happening in an instant. So it takes some time to process and to send you back the result. So in order to tackle this kind of asynchronous programs or asynchronous code, we try to use async functions. Next, I want you guys to create a variable called accounts. We are going to fetch the accounts from our wallet. I'm going to say await web3.eth.get accounts. Now what this await keyword is saying is that don't process anything after line 42. So if I have some code here, it will not process this until this get accounts function return its result, right? So the compiler stops here until this function returns some value. Only after it returns, it processes the line 43, 44 and 45. Okay, next I'm going to console log this accounts. Let's see what we are getting. Console.log accounts. Okay, let's save this. So in case if I catch any error, I'm going to log that as well. Console.error. Okay, great. Now let me call this function deploy. I'm going to save this. I'm going to say okay, everything looks fine. I'm going to say node deploy js. See, it doesn't happen immediately. It takes some time to fetch the result. So that is why we are using that asynchronous function. So we got this array which has one address. Now if you look at this address is same as what we saw in the MetaMask wallet. Yeah, this first account which we have 5 ether balance, it is one starts with 104 and ends with 1b. Starts with 104 and ends with 1b. Yeah, it is the same account. Now let me try to print the account balance. For that I'm going to say const account balance is equal to await web3 dot eth dot get balance. So this takes one argument. I'm going to pass this account address. Now for this I can use this variable accounts of 0 because this is an array. This accounts is an array. Within that array I need to access the first element. That's why I'm indexing it as 0. And let me print this account balance. Console.log balance account balance. Okay, let me save this. Now cancel this and run the deploy.js file again. It takes some time because it's an asynchronous function. Yeah, I got the so as you can see I have 5 ether in this account. Now the reason you're seeing this, how much is it, 1 2 3 4 5 6 7 8 9 10 13 14 15 16 17 18 zeros after 5 is because this balance is represented in the form of v, which is another unit of ethereum, or another unit of ether. So 1 ether is equal to 10 power 18 way. So this is nothing but, so 5 ether would be equal to 5 into 10 to the power 18 way, right? Now that is exactly what we are seeing here, 5 followed by 18 zeros. It is represented in the form of way, which is another way of representing ether. Now we have arrived at the most exciting part of this video, where we try to deploy the contract on the Ropsten TestNet. So let's get started. Now I'm going to create a variable called contract. For this I'm creating a new instance of web3.eth.contract. Now contract is a class. I'm creating an instance of that class. Here I'm going to pass the ABI, which is this one. What I'm going to do is I'm going to json.parse the ABI, because ABI has been converted to string here, and I want to revert it back to an object. I want to convert it back to an object, so that's why I'm using json.parse. Now this doesn't deploy the contract right now. What we have to do is I'm going to call another function on contract, which is deploy. This takes an object as an argument. In this object there's the data property, which is nothing but the bytecode of our compiled Solidity contract. Now this bytecode we already stored it in a variable, which is nothing but the property associated with this contract object. Now I'm going to take this variable and inject it here in the data property. I'm assigning it as a value to the data property, and after this I'm going to call a send function, which takes another object as argument, and this from key should be assigned with a value accounts of 0. So accounts of 0 is nothing but this address, right? So I'm trying to deploy this contract or this bytecode using this address. That is what this statement means. Now again, this is an asynchronous code, so we need to put an await, and let me get the, let's say, response. I'll call it response. Now let me console dot log this response. Just in case if this is an object, let me json dot stringify it so that we can see the entire object in our console. Okay, I saved it. I have saved the file, and let me try to deploy it again. Guys, there is a small correction. I want you guys to remove this json.stringify for this response. Then I want you guys to remove this to json.stringify. We don't need this. Just remove that and save your file. And one more thing, you need to add this gas. So this is nothing but the amount of computation, that the maximum amount of computation or the amount of ether that you're willing to spend for this, transaction or deploying this contract. So I'm giving 1 million gas. You guys can give how much ever you want, as long as you have enough ether to compensate for that. Okay, so let's save this. So in the data field, I need to provide bytecode, not ABI. It has to be bytecode, because bytecode is the data which you are sending it to the Ethereum network to deploy it, right? So it is not ABI, it is bytecode. The data field should be bytecode. Okay, now save your file. Let's run the deploy script. And last correction, guys, you need to remove this json.parse. Since we are not stringifying it, there is no need of parsing. We have removed the stringify json.stringify here, so there is no need to parse in this line of code. So save your file, run the script again. As you can see, guys, we have got the response. So this will not happen immediately, guys. You need to wait for some time. It takes some time to process and return the response. So here is my contract address. I hope that is the address of the contract. Let me check once. Okay, so here is my contract address. Now what I want you guys to do is go to Ropsten Etherscan. Type Ropsten Etherscan on Google, click on the first link, and here you can paste this address, search for it. Yes, you can see the contract has been created. I'll zoom in a little bit. Okay, so it was sent from this address, which is the address of our contract. Let us check if that is the case. Yes, starts with 104 and ends with 1BE. Yes, that is exactly our account address. Starts with 104 and ends with 1BE. So our contract has successfully been deployed, guys. For more information, you can click on the transaction, and here you have all the information, like our gas limit was 1 million, so that is this part which we specified in our send function gas. So it is 1 million gas, that is our max limit, and the transaction has used just 135,091, that is 1,35,091 gas, which is 13.51% of your 1 million gas limit. And this was your, okay, so this is your nonce, and this is your input data. This is your bytecode of the contract which you wanted to deploy. and somewhere you can find the transaction fees. Yes, here it is. So this is the total transaction fees. So this is calculated by multiplying this total gas used, then base fee per gas. So 135,091 multiplied by 10 would give you so many ethers. Next, I want you guys to save this address and store it in a file. We don't want to lose that address, guys, because we need that address to send transaction to that contract. So I'll just save it as contract address.txt. I'm going to save it here. Okay, now let's run some transaction. So just to recap what we have done until here, we had created a hello world smart contract, we created a deploy script, and we create a contract address.txt to store our address, and then we stored the seed phrase, that is the MetaMask wallet seed phrase, in a file, and then we installed a couple of dependencies like web3, solc, and truffle wallet provider. We created a file deploy.js in which we are trying to deploy our smart contract. So we compiled our source code, then we extracted the ABI and the bytecode from our compiled Solidity code, and we created a wallet, and we created a web3 instance to connect to that wallet. Then we created a deploy asynchronous function, and in that function we try to get all the accounts from our wallet, and then we try to get a balance just to check if you have enough balance, and then we try to create a new contract instance using the web3 instance, and ABI is passed as the parameter into the constructor. Next, we try to deploy this contract using deploy and send function. In the deploy function, we have sent an object with key data and value bytecode. So bytecode is the compiled bytecode of our hello world smart contract. And then we have used our first account address to deploy this contract, and the gas limit is 1 million gas. Then we have copied our after deploying, we copied our contract address and we saved it in this contract address.txt file. We need this address, guys, so we need this address for future interaction with the contract. Now that is it for this video, guys. So this is just a simple hello world contract which I've done to explain you the basics of Solidity, and as well as how to deploy a simple smart contract into the Ethereum network. So if you guys want more videos like this, let me know in the comments down below. If you like this video, guys, please like, share and subscribe. Thank you for watching, guys, and I'll see you guys in the next video.